Imagine a machine so precise that sunlight hits it, and electricity appears instantly without a single moving part. But here's what nobody tells you. Every solar panel begins as ordinary sand buried deep underground. But here's what nobody tells you. Every solar panel begins as ordinary sand buried deep underground. And this is where it gets extraordinary. Factories create crystals purer than many laboratory-grade chemicals on Earth. One invisible speck of dust can ruin a solar cell worth more than an entire truckload of sand. The world now produces enough solar panels each year to cover entire major cities, with electricity generating rooftops. The world now produces enough solar panels each year to cover entire major cities, with electricity generating rooftops. Over the next 15 minutes, you'll follow one grain of sand through fire, chemistry, robots, and brutal testing. What happens next surprised even experienced engineers. Sunlight is actually the easiest part of the entire process. Every solar panel begins with quartz, not ordinary beach sand. The purest deposits lie deep beneath ancient mountains and deserts. China, Brazil, Norway, the United States, and India supply much of the world's highest quality quartz used for solar manufacturing. Mining crews blast solid rock, then crushers reduce massive boulders into smaller fragments ready for purification. Powerful magnets and washing systems remove unwanted minerals before the quartz travels hundreds or even thousands of kilometers. Freight trains, cargo ships, and heavy trucks move millions of tons of quartz every year across continents. At the refinery, electric arc furnaces roar beyond 2,000 degrees Celsius, or nearly 3,630 degrees Fahrenheit, separating pure silicon from oxygen locked inside quartz. Carbon reacts with molten quartz, pulling away oxygen and leaving behind metallurgical-grade silicon nearly 98% pure. And that's only the beginning, because next these flawless crystals must grow perfectly, or the entire solar panel can fail. Inside a crystal-growing furnace, purified silicon melts again at 1,414 degrees Celsius, or 2,577 degrees Fahrenheit, glowing brighter than a sunset. A tiny seed crystal slowly touches the liquid surface, beginning a process that demands almost impossible precision and patience. The crystal rotates at roughly 5 to 20 revolutions per minute, rising just 1 to 2 millimeters each minute to stay flawless. If the temperature changes by even a few degrees, microscopic defects can spread through the entire crystal within minutes. After nearly 2 full days, one perfect silicon ingot can weigh more than 200 kilograms, ready for the next transformation. Diamond wire saws thinner than a human hair slice the ingot into ultra-thin wafers with astonishing accuracy. Each wafer measures only about 150 to 180 microns thick, thinner than a sheet of ordinary office paper. Robotic vacuum arms lift every fragile wafer gently, because one tiny crack can destroy hours of expensive manufacturing. But cutting the wafer is only half the challenge. Next, invisible chemistry transforms plain silicon into a powerful solar cell. Now the real transformation begins. Every smooth silicon wafer must become an electrical device, atom by atom, inside an ultra-clean factory. First, automated cleaning baths wash away microscopic dust using ultra-pure water with resistivity approaching 18.2 megacentimeters, nearly free of contaminants. The wafers enter heated chemical solutions around 80 degrees Celsius, or 176 degrees Fahrenheit, removing invisible oxide layers and organic residues within minutes. Next comes surface texturing. Controlled alkaline chemicals carve millions of microscopic pyramids that trap far more incoming sunlight. Those tiny structures reduce reflection dramatically, allowing the finished solar cell to absorb significantly more usable sunlight every single day. The wafers finally begin to resemble real solar cells. But one spectacular step still decides whether they'll produce electricity efficiently or fail completely. Now comes the moment every engineer watches closely. Without microscopic metal pathways, a solar cell can never deliver usable electricity. Each conductive line must collect maximum current, while blocking as little sunlight as physically possible. It's an extraordinary engineering balance. The printed cells enter firing furnaces reaching nearly 750 degrees Celsius, or 1,382 degrees Fahrenheit, permanently bonding silver contacts to the silicon surface. Electronic testers instantly measure voltage, current, efficiency, and microscopic defects, rejecting weak cells before they reach final assembly. Only cells with nearly identical electrical performance join the same panel, ensuring balanced power generation throughout decades of operation. Robotic solder machines connect individual cells using flat copper ribbons moving with astonishing speed and microscopic precision. Dozens of connected cells become a complete electrical string, carefully positioned onto tempered low-iron glass for maximum light transmission. Everything now enters the most demanding tests imaginable, where heat, ice, storms, and time challenge every single solar panel before approval. Before any panel reaches your roof, it must survive tests that simulate decades of sunlight, storms, freezing winters, and scorching summers. After passing international IEC 61215 and IEC 61730 standards, each panel finally earned permission to power homes across the world. Think about this. Every sunrise now powers millions of homes because of factories quietly building solar panels around the clock. Today, global factories manufacture well over 600 gigawatts of solar panel capacity every year, and production keeps accelerating. What happens next changes everything. After decades of service, these panels begin an entirely new journey through advanced recycling technologies. But before we leave this incredible factory, there's one final truth about solar panels you'll never forget. You just followed an ordinary grain of quartz through heat, chemistry, robotics, precision engineering, and decades of relentless scientific innovation. Every polished surface, microscopic circuit, and protective layer represents thousands of engineering decisions working together to capture pure sunlight. The next time you hold one of these in your hands, remember, it didn't just appear. Like this video, subscribe to the channel, and join us as we uncover the incredible factories shaping our modern world. Until next time, keep looking beyond the surface, because every everyday object hides an extraordinary story waiting to be discovered.